Hey everybody, it's mid-July and we've got a heat wave going this week, but I was able to get a little bit of welding done on the AC225. Got back to it and welded up a couple of these handles. Here's one here. I'm getting a little better at it. I build it up a little bit and then I ground off some of the spots that were just really spattered. And looking at it really closely, I could see now that there's like areas where it's not really, it's kind of like undercut, and there's porosity in there, pinholes, but it's pretty strong. And I might try and flow some more bead over this with a different type of rod. I think I found a rod that said I think it was 7024 or 7014 rod, and I think I was reading where that was a rod that's real easy to work with, and it's almost like a drag type rod, and that it flows a lot and it's good on thin metal. And I noticed that some guys mentioned that they'll use like the 6011 rod, which is they'll use that for like their root pass or whatever, and then they'll go over and clean up over it to make it look prettier with one of those other type of rods. So anyways, that one there, might call that almost done. And then got the other one. Bear with me a second. It's this one here. I kind of like the look of this one better. And this one on this side's not. That what it was like I got it welded, and then there was like some holes that I had to fill. So then I had to kind of like build up an area to fill in the holes. So that's why there's kind of a shoulder on that one right there. But again, it's pretty strong. Should just dented the top of my motor case here. I should be banging on that. Anyways. So I'm satisfied with how strong it is, considering I don't plan on dropping the backhoe attachment on the levers again. So what I've been using is these 3/32 inch 6011s. They're old, but they were in this package and they seem to be working okay. I noticed a lot of these larger rods that were out of the package, if I try and use them, even if I can strike an arc, if I stop halfway through and try and restart, I have a real problem restarting. And what happens is when the rod gets really hot, the flux coating actually cracks on it. So I think that's a telltale sign that these are just old rods. These are mostly, I think, 6011s, and then I pulled out some odd ones. I'll show you those next because I thought those were kind of neat. Oh, another thing I did is I spliced in, I added an outlet in the basement here for my my extension cord for my welder, so I can just run it out the bulkhead door now. And this is a junction box here, and so this cable up here is going up to the stove. This is my main feed coming in from the 50 amp, and then here's a short little piece going out. Got my outlet. And I plug in right there. Now I can just coil my cord up and leave it down here on the basement floor. And then when I'm ready to weld, I just open up the bulkhead, run the cable out, and plug in. So these are several rods right here that piqued my curiosity. I wanted to read up on them and see what they did. This is a 10016-D2 rod. And I found a lot of people asking the question about what this rod was, because they said, they got some and didn't know what it was for. And it's a structural steel rod from my understanding, and I guess it was used a lot back in the day. A lot of people commented that if it's been exposed to moisture, humidity, and it's not in an oven, it's pretty much junk, or you might be able to bake them and reuse them. That seems to be the case with a lot of these rods. This is the 7014. I appear to only have one of these. And then this is the 7024. Either one or both of those rods, I think, is the one that they talked about, that it really flows easily. And then this is the one that I thought was really cool. Never heard of this. And it says UTEC chamfer trode, and there is no numbers on it. But I went to the website for this company, UTech, and I went and looked through all their rods, and it turns out this rod is actually designed for gouging into metal. So it's not actually supposed to be a rod for laying down a bead. It's a rod that's supposed to be used for actually removing metal. So that's kind of interesting. A big chunk of flux is off of that one there. But I might, just for giggles, I might cut that with the with my little mini bolt cutters and fool around with that just to see what it does. I got a feeling as soon as it gets hot, all of that flux covering that's on it's just going to crack right off like the other old rods I've got. But welding the other day, went to fire up the welder, and well, had a problem. The cooling fan did not come on. So today I decided to open up the welder and find out what's going on. So first I had to take that table off the top. That was real easy. And then there's a whole lot of screws you got to take out. But I really only wanted to take this back cover off. So that wasn't too bad. And I exposed the fan, and I actually thought maybe the fan was going to be stuck or needing lubrication or something, but it spins freely. And so then I looked at the leads, and lo and behold, one fell right out. I realized that this wire has broken off or become disconnected somehow, even though the welder's been doing nothing but just sit here. Ooh, sorry for that being so foggy, but I just took this camera from the cool basement out here to where it's so humid that it fogged right up. So anyways, so there's the fan, and I just went and checked. I found online where there was a little diagram showing the wiring, and basically the two leads are supposed to just go to the switch. So I can see one of the leads goes right over to the switch, and the other one must go to that other side of the switch down in there, and for whatever reason it became disconnected. So I think I'm going to have to unscrew that nut and take that connector out and take a look at it. So I just laid the welder on its face, get a better look, but basically you can see this is one of the outputs from the switch. So the AC comes in at the top there through those two, goes through this double pole power switch, comes out the bottom from those two. One wire goes to the primary of the transformer on this side, and this one goes to the fan. Yeah, that other wire goes to the primary transformer. And so this wire right here looks like it should go right there. And again, how that became disconnected, not burnt off, but it looks like it just broke off. It's kind of weird. And I'm fogging up again. Alright, so this is the terminal connector, the ring terminal connector that I just took off of that switch, and I could see the remnants of the wire in there. So what they did was they just crimped that terminal connector at the factory onto both of these wires at the same time, and this one has broken off. So I can either cut this ring terminal off, strip both wires, and put a new ring terminal on there, or I can try and maybe strip some of this wire insulation off of this wire and solder it onto there, because this wire doesn't carry much current because it only runs the fan. Alright, this is a real down and dirty repair here, but I just basically I wrapped the wire, I stripped the wire back, wrapped it around there, and then flowed a bunch of solder right into there, and now it's a pretty good connection and it should be just fine. I've preserved the mechanical connection of the crimping that was original on the welder for the main current flow through this wire here to the primary winding, but at the same time I was able to tack on here, and that'll restore my fan motor operation. So now I just have to tuck this back down, and the tricky part's going to be getting that screw retightened, because you need to get to the front of the screw to get to the head. So I might have to remove a couple of screws off the front panel that allow me to drop this switch down out of position. Well, I was able to do it without removing the switch. I was able to stuff my big hand down here and use my long fingers to curl around and actually hold the end of the screw head up with my finger tip here. And because it has a star washer on it, as soon as I started to snug it up, it pretty much locked up so that I was able to tighten that nut. So now I can plug in the welder and test it. Alright, let's fire it up. Oh, hold on a second. Let's see where my electrodes are before I do that. Oh, there they are. Alright. Got to keep them separated. There we go. Alright, now I'm just going to button it up. Alright, all buttoned up and ready to go for the next time I weld. I got one more of those handles to weld, and then like I said, I might try and flow some of that other rod over the top of those ugly welds just to make them look a little prettier if I can.